And then topic 1, for the concept to be highlighted as we do questions. So we'll stick to the questions and then I'll be guiding on other things that we need to look at for you to be able to understand those concepts in those functions. Okay. So the first question, you can see topic 1, it's sets. So we must understand sets. So consider the subsets. We are given A to be negative 7,4. Now B is equal to 0,8. And C is equal to 1,15. These sets, they have the universal set U, which is equal to -8,14. Like that. So if I'm given these sets, what question do you expect? Find each of the following. Then display the solution on the number line. Part 1, A union C. Intersection B. Part 2, A complement intersection C complement. And part 3, B union C complement intersection A. So in sets, I think this is the most critical part. This is where we find it a bit difficult. I've seen so many lines that just gets mixed somewhere. So when you are given the sets of this kind, and you're asked to find each of the following sets, like part 1. So A union C. So let's go to A. A is -7 to 4, and C is 1 to 15. So I first get part 1, A union C. That is -7,4 union 1,15. When you are getting the union, the secret is here. My left numbers, -7 and +1, we get the smallest. So we get -7. comma 4 and 13, we get the largest. 13. So you are doing that if this one is less than this 4. Because now we're sure they intersect. Okay, now you're sure they intersect. So we get it like that. So this is A union C. The question continues to say, when you have your A union C, you need to intersect it with B. So now we have -7 to 13. Let's bring in B. B is 0 to 8. The intersection between -7 and 0, you get the largest. And between 13 and 8, we get the smallest. Provided that this number is bigger than that number. So we have the largest between -7 and 0 is 0. We get 0 with its bracket, comma 13 and 8, the smallest is 8. This is the solution. On the number line, I just go there with the answer. I'm not going there to solve. I'm just putting the answer 0 to 8. After I put the answer again, I will remember that the universal set is limited. It doesn't go to infinity. It goes only up to 14. So I close there, I put 14. And up to -8. So it close, you put -8. Like that. So our set is open, close. Like that. So to get the union of two sets, the intersection of two sets, if you pick that art, it saves time because you don't have to start drawing lines. So, but in here, we're going to use what? So the first question, I've used this method. Then the second question, I will use a number line, of course. So as we can see, and I have decide which one is using. So A complement intersection C complement. Here, you can choose to get A complement and to get C complement, or use the Morgan's law. Morgan's law says this is the same thing as A union C complement. Meaning, I will have to get A union C. After that, I pick the complement. So now here is in the number. So up 14 and up to -8. Then A is -7 up to 4. Open up to. That's A. B is from 0, I mean C. C is from 1 up to 13. So close up close. So it's a C. To get the union, I shed every A plus every B, I mean every C. So up there. So the union, A union C, is actually equal to -7 to 13. What? Okay. But the question says, can you find the complement of this set? So we go on the number line and say, okay, we're here for the complement. So since you are closed at 13, it will in the complement it will okay. But the one on the inverse remains the way it is. It's open at -7, it will close in the complement. So we have -8, -7, closed, closed. Union 13, 14, closed, open. And then the number 9 is right there. And because I have the red thing, I'll do like that. I can even write that, oh, this is a complement with just a slip on. A complement with just a slip on. Like that. So sets should be the priority when we go in the exam. You must not be accepted. And sets is a must thing. You can't go in an exam and there's no question on sets. Then you do not go for that exam. And we don't expect much things. We expect this kind, intersect two sets. Can you get the union? Can you get the complement? That's all. So I can have the complement, I can intersect, I can get the union, then I'm done with sets. I mean, if there is numbers 1, 2, 3, 4, that will become even easier now. But intervals, that's why I must pay attention. So we got the next one. So we have part 3 there. Part 3 is B union C, which B union C complement intersection A. Yes. So we have B 0 to 8, C 1 to 13. So B 0 to 8, C 1 to 13. So first we get B union C. B union C, we say 0 to 8, union 1 to 13. That is between 0 and 1, we get 0, the smallest. Between 8 and 13, we get 13, the largest. So now we go for the complement of this. So what is B union C complement? So since we have the universal set to do it, the universal set to be, is it -8? We do that at the 14. We do that. So you start from the end of the universal. You start from -8. That's the furthest you can go. Move all the way up to 0. But look, you find 0 is not included here. You include it. There's still some space. Again, we'll start from 13. Since 13 is included there, we'll exclude it. Go all the way up to 14. Like that. So when this happens, you see, these can't be intersected again. The reason why I've used union is because you cannot put them together. They are disjoint. Okay? So now I want B union C complement to be intersected with A. What is A? A is from -7 to 4. So we'll have this. union intersection. We bring in A minus 74. That is, we start with this one. Let's set that down. The intersection. So minus 8 and minus 7. We get the big one, which is minus 7. 0 and 4. We get the small one, which is 0. Union. This is 13, where the set is starting from. This is 4, where it's ending. So the ending value is less than the starting value for the other one. So they do not intersect. So this is the only thing we have in common. And on the number line, it is 14. This is minus 8. So we just need from minus 7 up to 0. Open. Conclude. That's it. We have any questions? Okay. We can move to question 2. To B, that was A. So B, and simplify the following. Part 1. A, A intersection B, complement union A minus B. Complete. Part 2. Part 2, we have A intersection A union B union B intersection B union C. Like that. So now, let's see. Let's start with the first one. What do we use to simplify cells? The laws. So we use the laws. Part 1. So the first thing we do is to attack the minus that is inside. So we have A intersection B complement union A. The minus means intersection B complement. Okay. Then you come back and distribute the complements now. So now we have A intersection B. There's a complement already, another complement that's come from outside. It changes this union to intersection. And then we'll have a complement outside here. What does it do? Then now the two complements will cancel each other. It will remain with A intersection B. Okay, intersection. That complement comes inside. Union B complement, it just remains B. You see? Then we now have, we distribute again. So we're distributing now A intersection B intersection A complement. Union, this one. Union, again, A intersection B intersection B. So here we have A intersection B. It's that part which is common between A and B. So if I do this, we mean this part. This is A, that is B. Then intersection, the outside of A. So look, this part is in A. So if you want to intersect with something that is not in A, then you cannot have anything in common. So empty union A intersection B intersection B. So you want to intersect this piece with B. So you still have this piece in common because the other part of B, there is no A intersection here. So here we just have A intersection B. Now, any empty set union any set, the answer is that set. Like that. You just need to take your time. You just take your time. Then the second one, we use, again, we're using laws. So you have A intersection. So A intersection A union B. Union B intersection B union C. Look what happens. A intersection A union B. So if I have two different operations, intersection and union, and one set appears twice, then that set absorbs the two sets that we have there. Union, the same thing happens here. The B appears twice with different operations, so B absorbs. So here you can simplify it. Unless we are told something. That's how cheap it is, that one. Okay, so cheap. Let's see. Let's put C. So C.
I have a question to proceed before you proceed.
Okay.
Then go ahead.
Hello?
I can ask a question.
Yeah, you can ask.
Yes, I'm a bit confused. Why have you left out C on the final answer?
Okay, so we left out C on the final answer because the analysis is like this. If this is B and this is C, when you say B union C, it's everything. Intersection B, B is here. And the answer is the part shaded twice. So you see, the part shaded twice is just B.
Mm.
And from the first one, it was just A. That's how we ended up having A union B.
All right, okay, thank you.
Then part C. If you are told that A is a subset of B, and A intersection C is empty. Simplify. A intersection A union B intersection B intersection A intersection C. So you are told A is in B, but A and C do not intersect. We don't know how B and C are related, but we must simplify. So what we'll do is, since A is in B, and from the previous analysis, the first part is just A, this whole thing. Because you have A union B, that's B, but A intersection B, that's A. Intersection B intersection A. Since A is in B, B intersection A is A. Intersection C, but we are told something. We are told this guy is empty. So end up having A intersection empty. And A intersection empty is empty. You see? So even if we don't know how B and C are written, for as long as we know how A and C are written, we can do much things because A is sitting in B, and there's no part where they intersect with C. So using just that thing, we have managed to evaluate things until we have a very, very small set which is empty. Okay. So today I was just doing to display the platform. Make people be comfortable with the Zoom setup and how we progress. This is how the view is. So we try to be as slow as possible so I don't miss a concept. And then for tomorrow, we're expanding more on sets. So we do sets, we do complex. We'll talk about binary. I will talk about irrational and rational numbers, the real numbers, of course, in question form. So here we'll just be doing questions. So when we do questions of this kind, if you go back to the notes of the theory, you find that you don't have to do anything. Because you find in the theory, there are questions that are asking to find the intersection, the union. I mean, things that we have done. So if I go through this work, it means I can intersect two sets. I can find the union. I can find the complement of the set. Of course, we are still doing an example tomorrow on sets where the universal is the whole line. We want to see how to appreciate infinite and infinite, how they come in, what's the difference when the set is limited, like the one we have today. So we do both of them and then see what the different things. So because tomorrow we're doing a double session, so we'll have the 40 minutes plus the other 40 minutes. Today we're just doing, and then the class will be uploaded, of course, in our group. So we have to